Hey folks, welcome. Thank you for joining. This is the Oracle Autonomous Database Learning Lounge. I'm Marco Senasivia, part of the product management team for Autonomous Database. And today we're going to have a very, very cool session on continuous application availability, right? So if you recall from the last session that Nilay did, we were talking about, high availability and disaster recovery, right? So he mentioned basically how to work with the application, right? So for the session today, right, we're going to have Anil Nair. He's a distinguished product manager, and he's going to be basically introducing you guys to the concept of the continuous, application availability. But also, he's going to talk about how that is, designed to basically hide any interruptions at the database level, right, that goes to your application, right? So he's going to be showing you, how it works the same way for all the different databases. And he's going to focus on some of the autonomous database use cases in particular, right? So at any time, we're going to have open Q&A. So if you guys have questions, please make sure to type them in the Q&A section of Zoom, okay? And then we're going to use the chat section to actually post links to you guys, all right? And then the recording of the session and slides is always available at the bit.ly/ADB Learning Lounge, as you see on the screen here. So these are just basically a list of important links. So if you're new to Autonomous Database, we have a Get Started page. It's the great, place to start, right? That's the QR code you see here. We have also LinkedIn and X. And for asking your questions, we have the Autonomous Database in Stack Overflow. But also, we have an Oracle Developers Workspace on the Slack. So you can see the link down there. And that's very useful because we are also monitoring that space, right, for any questions as well. Again, thank you very much for joining us, Anil, today. I'm going to stop sharing my screen and let you share your screen and take it away.
Perfect. Thank you so much for having me. I'm Anil Nair. I'm the product manager for Real Application Clusters, ASM, application continuity, pretty much everything that resounds around continuous application availability. It was interesting when Marcus, whose name is very similar to my boss's name, Marcus, who requested this session. How could I say no? And a very interesting concept we have here, in the sense that everybody wants their application to be available. And it's very easy to do this if you're using our recommended solutions, and obviously autonomous, which uses Oracle RAC and ASM and all those other things below the the offering, makes it very easy for you to consume it. So I'll go over a few of these slides and try to explain. And thanks again for the poll, because that really makes it easier to plan for future sessions too, because if we have a lot of folks who are not aware of some of these things, then we need to spend more time on that. And if people are already using it, we want to learn from you what are some of the obstacles that you face so that we can improve our product. So having said that, some of the topics I'm going to talk about, I have blogged about it and shared, in presented elsewhere. Feel free to look at some of those links, and again, feel free to send me any questions on these. Moving on. So what we're going to talk about today, right? We have this concept of continuous availability, and kind of explain exactly what it means into the technical terms for us. What is maintenance without impact? Then we'll talk about transparent app continuity / app continuity. And I have some of the tips and recommendations spread all over in the slide deck. So what is continuous application availability? Now, we split them into two, actually. So there is something called as a planned outage. So typically, let's say you are going to that on the Saturday or Sunday that data center is going to lose power for any power upgrade things. Obviously data centers today have multiple power sources and all that, but let's not worry about those. What I'm trying to say is, in future that there is something that you got to do. For example, it could be an app server that you need to replace or something, right? So you want to make sure that at that time the end user doesn't need to know what's going on. What that what that means is the performance of that application and any errors that they may receive both needs to be taken care of. So that's the first part, which we call as planned maintenance. The other thing is the exact opposite, right? It's unplanned. It's an unplanned outage because something happened, like there's a power failure or some, memory bus suddenly crashed. That means that the node has to be taken out, or a case which takes away an important part of the application. What does that mean? Is like your application has some kind of the clients, the drivers, the app servers, the database servers. So anything in this ecosystem has a unplanned outage. You still want to take care of those and make sure that it works, it continues on. And that's the hard part. Predictable performance, and this is the other harder part in the sense that predictable performance is hard to get. Predictable performance means if you have an SLA of say 5 seconds, so everything has to be finishing in that time, and there is an increased amount of workload coming in for whatever reason. Maybe your application is suddenly really adding more and more users. You need to make sure that your SLA is predictable. Autonomous gives you the best things for that because there's a lot of knobs by which you tune the knobs, and then your resources can increase. So kind of you have some protection there. There is all of these things can be achieved. It just needs some planning. Okay, I'm not trying to tell you that, hey, you set this underscore continuous application availability equal to true and boom, everything works. No, that's not exactly how it works. There is some things you need to plan. Like, for example, you need to plan for making changes to the application stack. Maybe there's some driver issues. I had a customer who's using really, really old version of the driver, which doesn't understand some of our newer connect strings, connection settings itself, and then connection pools. Some of the connection pools work with varying levels of things. You may have some application that does things like DBMS output. And I put it out there because you think that it's so rare, but I actually saw somebody running a report with DBMS out. So it's not a good thing for these things to be used. In which case, what I'm trying to hint at you is that some of these you can easily do with minor configuration changes, as in drivers or connection pool settings. Some may require a little bit more involved, like you actually need to go to the code and change it. Now, depending on if the code is or the app is written by you or maintained by you, or it's a commercial app or whatever, that may impact how much you can benefit from it. That doesn't actually reduce the focus of this, right? Because remember, let's say that report using DBMS output was invoked once in a quarter. Well, at least you have better coverage when that report is not being run. So it's not like it's not like a binary on and off. It's basically you still get some of the benefits, but in order to get all the benefits at all the times, you may need some changes. Okay. Now that's the first part of the problem. Now the second part of the problem, which we work with some customers of ours, is, hey, I have 400 applications. What should I do? This problem is no different than the problem we had with RAC about 20 years ago when RAC was introduced. Like, customers would come and say, hey, what application should I move here, right? And that is a very hard problem, which is easy if you standardize, right? And standardization is what we recommend. And here also we recommend standardization in the sense that, okay, let's start with a high-level checklist. A high-level checklist is basically understanding your apps. This is where it gets kind of like dicey because a lot of our customers have workforces divided into DBAs, developers, app owners, application managers, and they are all trying to do the right thing for the business, but they also need to talk a little bit more to each other. For example, a DBA may not be aware of what is a connection pool and the app server settings and all that. So this is a joint venture. This is kind of like a joint venture where you need to go and sit down. And by the way, if you go to that URL, you would get that questionnaire where basically the questionnaire says a question like, hey, how are you connecting? And then the first thing you find out that, okay, out of my 400 connections, 10 are actually only using the default service. which is really bad, right? So that you don't want to do. You want to make sure that those definitely cannot use all the benefits. So you need to make sure that those need to be changed to use what we call as a user-defined service. Are they using a proper connect string? Sometimes they use connect strings with SIDs and stuff. With autonomous, you get a wallet and you get all those things with the correct settings. But what I'm trying to say is when you go to the other side and see, you may see that, hey, they are not even doing some of these things correctly. So these are some of the things that the questionnaire will start. So you can then begin to put your 400 or 200 application thing into different buckets, saying, okay, this one is easy. This one is some changes. This one, well, this I really need to focus on. So at least you divided it into a manageable bucket so that you can then start. So this is how we tell or we recommend to our customers when we talk about, where do you start? People need to understand is this concept of boundaries. So what is a boundary? Is basically a commit. Basically, when you have a connection, you do some work and there's a commit. That is a boundary for us. What is that boundary used for? Well, the boundary is for doing things, like for example, if you want to move some connections, that's a very good point to do. You don't want to do it in the middle of a transaction. Now, again, remember, planned, it's easy. Unplanned, it's a little bit more involved. Why? Because in a planned, you actually know when the commit is done and the commit is acknowledged to the session, and we can actually get in and do things to it because via an inbound ONS notification or via a service relocate or whatever. Now, for unplanned, it's a little bit complicated because for unplanned, what happens is, you could be having the most complicated case. For example, let's look at a case where you do a commit, and the session has said commit this thing. I updated blah blah tables. I committed. Now the log writer goes to write to it in the back end, and the log writer, as it's writing, there's a crash. There's some power reset or whatever. Now when this application, the session fails over to the other node, assuming there are multiple instances, we need to know what is the outcome of that. And when you ask the outcome, there could be two outcomes, right? Either the log writer finished writing and in the process of sending and commit acknowledgement to the foreground crashed, or it actually did not write. And regardless, we take care of it with app continuity, and then we give that information about whether the commit has been done or the transaction has been committed, or whether it will redo that commit and then give and all of this is automated. But the point is it requires a little bit more work on the back end, which is the database server, to do it. So how do you define it? Well, most of the time, we can easily figure it out automatically. And as I said in the right-hand top, most of the pools with Java and TAC, we can automatically figure out this unit of work. The second part is, with different databases, different applications, it's extremely hard to figure out what is the timeout that we need to give. And neither are good solutions. For example, if you recall back in the day, when you do a shutdown, right? If you could do a shutdown and then things would take forever because one person has connected and doesn't disconnect. If some customers don't want that to be, killed or that session, or some customers want that to be killed because the downtime or the planned maintenance is limited window, right? So we have this thing similarly in autonomous or in any database offering where we want to make sure that how long should I wait before I actually start doing things? And so there is this new view that we have, which is called as service drain timeout advice, which kind of tells you that, hey, you know what? Your application has been running on this database for a while, and in the past, these are the different buckets after which the connections have drained out. What that means is it gives us and you as an advice whether, when you do a maintenance, like, planned maintenance, you can figure out what's the time that it took last time, roughly. So if you have 1,000 sessions, say 800 sessions, drained within 1 second, and, about 100 sessions took 20 seconds. So you have a fair idea about how long does it take. And this view gives you that information depending on how much time the application has been running on the database. And then you can then execute the command in typical clusters. You would do sysctl, but in autonomous you would use this DBMS app cont admin procedure, and then you can set that draining. What that gives us as a value is what's the time we should wait after which we start killing sessions. And when we do this, we basically return these connections back to the pool. And because what we want is we want to make sure that the pool should know, because the pool has some settings like min connections, max connections that it automatically maintains. When the connections are sent as back, then it can automatically update its set of pools connections based on the min max settings. So if you have a 2-node cluster, let's say, and you're trying to say, hey, I need to have 30 connections in my pool all the time, and because of this draining 15 is returned, then you need to make sure that the application server needs to make sure that it initiates more 15 connections from wherever the database can provide. And with autonomous, you don't need to care, right? It's all taken care of in the backend. But just for example, providing an example, I provided that with how it works. So when you say we return the connection to the pool, there's obviously a fan event set, because this is important, that there may be sessions or connections in the connection pool that we need to mark as don't use, because that is pointing to the instance which is going to go down, right? So that is important that we kind of make sure that the connection pool does not have what we call a stale connection. So that is taken care by the ONS, the notification service, and we make sure that the pool understands that. Now, when I say pool, typically I'm talking about the Oracle UCP. Obviously we have WebLogic, a very good we have a very good implementation on WebLogic, and we have varying level of implementation with the others, right? Meaning WebSphere actually is very good, as I hear, JBoss and WebSphere. And then as we get into these really, really arcane use cases, some like the latest one that I've been hearing a lot, it is Hikari, right? And Hikari has certain things that it has implemented as part of the larger, requirements. Certain things it doesn't, and there are a lot of pros and cons to it. For example, for Oracle, we think they have not implemented it, but if you look at it from a developer perspective, because Hikari is very thin and very lean, app server, that's why it is easier to use. That's what the developers say. But the problem for us is if we say, hey, do certain things, and we expect the app server to do something, meaning we can only send an event and we expect the app server to do it. If the app server does not have any code to catch and react to that, then really nothing we can do. Right. DBAs in a typical world would use relocate, sysctl, as I said, but in autonomous, as we say, we understand you don't have an access to the command line and sysctl commands, but we provide you with the DBMS app cont procedure, so you can actually manage it yourself. And once you do this, these sessions are drained automatically remember, after the commits. So all new sessions request or connection requests go to the other instance or redirected, and then idle sessions are also redirected, and eventually, we are able to provide what we have intended, which is essentially a no impact, planned maintenance activity. This is a simple screenshot of a particular app server, in the sense that it's much easier to add the required, drivers and all those to app servers. So in this case, we just needed to add some of those, ODBC, UCP, ONS, jar files to the class path. So it works for us. Most of the time, as I said, most of the modern app servers that we have worked with, and I keep saying modern in the sense that which have been traditionally used with packaged applications, right? WebSphere and all that. Works perfectly well. We have seen certain cases where even though we have provided they cannot just use it, in which case your benefit or your benefits in terms of having this continuous application availability gets impacted pretty soon. Okay. The third thing is, okay, you have, especially with different connection, the app servers. And remember, app servers are created to talk to different databases, so they may not understand Oracle much as a database, right? So we understand that, and we provided some, extra facilities for them. For example, you can actually say and define how do you, test whether a connection is good or bad at the app server level. Basically, what that means is, in this case, I put rack, but this could pretty much be an autonomous database. Essentially, when services are stopped or relocated using whatever DBMS app count, the database marks the sessions to drain, and the application or mid-tier, whatever we want to call it, would test their connection. And as I said, what is a test? Meaning there's nothing called as, go initiate a connection request and wait. What we do is we provide them with various pre-built and predefined tests, or we actually provide a way by which we can tell them what to do. For example, in this case, we can tell them like, hey, you know what? Execute DBMS app count admin add SQL test, select count star from dual. So if select count star from dual fails, that means that connection is bad. So you can do something else. And the way we can do it is we say, add that SQL connection test, enable it. And then you can also look at, select star from to see what are the available DBA connection tests. This is again provided for those app servers which does not have an inbuilt, and I'll actually show you some of the app servers which have it already. On the client side, obviously some of these things need to be validated. For example, the set validate connection on borrow and is valid needs to be, checked. On the database side, as I said, if you select star from that, not star, select that SQL connection test, you would see all those, whatever has been added. It doesn't matter what it is in terms of performance. Like, obviously dual has only one row, so count star versus one is same. It doesn't matter. The point is there is a mechanism by which the app server understands that even though it doesn't speak the Oracle lingo, it knows what to do. And on a failure, it knows what to do. And that kind of works for our purposes. Okay. And as I said, this is some of the typical ones. You generally do not want to change any of these things. Most of this is good. For example, for a WebLogic, they use select one from dual and all that. You do not want to edit any of those for those well-known cases. You only provide it for those app servers which doesn't understand and therefore need that change. Fan is a very important component in all of this, because one of the things that at least in the rack world we know is that things that are interrupt or dead, they cannot tell you anything. For example, if your network is bad, that you reach to the your public network, it waits for TCP timeout. Now applications, you don't want your application to wait on that. For example, think of it, autonomous is working perfectly fine. The database is saying, I'm good, all the checks are good, but you're saying, hey, I can't connect to the database. Now, there's so many things that could be wrong, right? You could maybe have some incorrect drivers or whatever, but it also could be the network. How do you find out? And the network is very complicated, because if you look at it, most people nowadays do not directly connect to the database. They go through these various layers, right? If I'm on my mobile phone and I'm trying to look at Fidelity or Charles Schwab for my stocks, it goes through from my home network to the local provider to wherever the server is. Any of that could be bad. And so what we try to do, at least from our end, is across this network, we try to tell you that if any of these things is bad, we try to reach out and say, broadcast that. So you don't wait for TCP timeout. Now, obviously, it requires you to be, you or your client to know this, how to use ONS. And as I said, for most of the Oracle stuff on the left-hand side, all of these, not just drivers, but basically all these implementations uses ONS by default. And ONS, it's not just for one type of error. ONS also tells you any kind of event that occurs on the database, we kind of propagate that down the chain. We don't even worry about what it is. on the client side, you need to make sure that you're prepared, your setup is ready to receive those ONS notification. And for that, we recommend that this is a good connection string that you use. And that will make sure that your ONS is actually working. There's some minor things that you need to make sure, like for example, ports need to be opened, and because in the cloud everything is closed, and you need to explicitly open ports like 6200 or whatever. But essentially, once you have all that mechanism in place, you would get all the events. Now, in the older clients, like I said, you need to actually set oracle.ons.nodes, and you give the server names and all that. Nowadays, you don't need to do it. I would not recommend even using 12c. I just put it out that slide out there because we found out a lot of our customer base who using the traditional applications are using older clients, and I just put it out there. But mainly for the newer ones, once you have the wallets, once you have everything set up, these are by default set for you. Okay. For OCI, we have certain, there's an Aura access file, XML file that you can actually put all the wallets and the ONS specific things. By default, we give you a pre-configured settings. Obviously, you can optimize it to or set it for your environment. And similarly for ODP.NET, the same thing, right? You would actually see some of this fan in the connection strings and all that. For example, you would have this HA events equal to true. And the benefit is that regardless of where you are, like for example, if you're using auto wallets, you make sure that the auto ONS is on. And all you do in this case is exactly as it's shown. Basically, for JDBC, you need to make sure that the correct classes are in your class path, and then you make sure that the system property is enabled for those, and you're all set. If you're an XML thing, again, the same things. You want to make sure some of those files are part of your class path, and then you want to make sure that your connection pool setting is clearly configured in the XML. For OCI, yeah, same thing. Aura access XML needs to be edited. For Aura access.xml, we recently found out that it's not really very well documented. So I actually recently had made sure that there's a note available with what are the things that you can change and what are the things that are possible for you to change. For example, in the Aura access.xml, one of the setting is what is the max size of the replay that you can do. What I mean by that is if you have a PLSQL procedure that is running and you change, say, a bunch of stuff before committing, so you change, say, more than what we can handle, so then we actually fail. And that more than what we can handle is defined in the Aura access.xml. Because remember, there is nothing for free in the sense that the more we have to track the changes, the more memory we need to allocate. And customers don't want like, hey, why is my one session using X amount of memory? Because we want to also make sure we have a fine balance between making sure your applications are available and making sure that it's a thin, lean client, right? So we want to make sure that both are set. What do you see from the fan watcher? This is an example, essentially on the client side. You can see if you basically want to say, hey, I am using autonomous and I want to make sure I want to see what are the things going on. Well, you can actually download this and see some of these things, the events. As a client side, as you can see, you can, if the service is down or service is up or certain events, and fan itself doesn't really care about the event. It's basically just an event forwarder, kind of like it relies on the client to take action. It doesn't worry about what is the event. Okay. The other part that we want to talk about, and again, since this is autonomous, so let's talk about autonomous. One of the things we do is with RAC, or when autonomous is running on multiple instances, there's nothing to do specifically, because remember, RAC is active-active, right? When a session fails over or drains over to the other side, there's no wait, because it's always active-active. And that's a very unique thing that, by the way, that is very different with autonomous and using our technologies. With data guard or active data guard, in this case, it takes a little bit more time, because remember, you want your app to wait, or the application to wait for the drain plus switchover, right? So for example, let's say the drain takes 5 seconds and this switchover takes 10 seconds. You want to make sure that your app timeout is set to a little bit more than that, because there is no point of this application failing over to the other side and waiting because the database is not ready to accept connection because it's still switching or whatever, switching over and all that. So there's some ideas that you need to have. That's why with Rack, you don't need to worry about the timeout because it's pretty much instantaneous just because of the fact that it's active. Okay. The part is very hard, as I said, to say whether you should use or not use AC or TAC. That's not the question. The question is, if you standardize it, you really get some protection. What I mean by that is, as I explained in the start, when you start with, typically most customers would have more than one application, and therefore you don't want to start with one application once and do this whole thing again and again. You want to start with, let's say, at a higher level using, for example, the questionnaire. But standardizing on TAC helps you in, right now, let's say you're level 0, you'll at least get a better or more than better than 0. What I mean by that is, yes, there are maybe cases that we cannot handle because of the app is doing certain things or not correctly configured or whatever. And the good thing is, as you standardize with the base of this as TAC, everything incremental that you go is going to give you more and more benefits. So unless you start with that standardization, it's the first step is the most important step, in other words, right? So why is that? Because remember, app continuity or TAC, or again, I interming use TAC as and AC, but for the purposes of this presentation, both are very similar. The way it's different, I'll explain in my last slide, and that way you can decide which one to use. So in a normal case, right, it's very easy. Rack has had the idea of detecting a failure and letting the application fail over to the other side for the longest time. I think even in 11.2 it was all working. The problem is when you fail over, what do you do? Is the commit outcome of the last thing understood? Can I continue where I left? Those are the things which we did not know, which is what app continuity helps. For example, here, app continuity, we kind of provide you with this interesting thing called draining. Draining is so important because if you have 1,000 connections and you fail over without draining, it could be a connection storm which could affect or make your existing connections on the same node go slower and impact your SLA. So that's a good case. We provide you draining. The problem where we need to do replay is typically during, for example, unplanned maintenance, and for those which does not drain, right? So you remember I told you that we tell politely that, hey, drain in 30 seconds. And some sessions would say, no, I'm going to continue on this. So that needs to be killed. And when you need to kill them, we try to kill them across transaction boundaries. But if we cannot detect transaction boundaries, we just kill them. When you kill them, they need to be replayed. Whatever they were doing, we need to replay. We need to figure out what was the last outcome of the transaction, and then we need to replay. Again, we are doing this without talking back to the user interface layer. So we are trying to kind of catch this in the mid-tier itself and redo it. So all of those things are done. The last phase being, we use kind of a transaction guard to guarantee the commit outcome, and we do provide APIs in the DBMS app cont for the user itself to figure out and what is the outcome. So for example, if you say, hey, you know what, I have my own code, it's not a traditional, what do you say, application that I purchased off the shelf. We maintain our own code. Can I use this to find out the last commit outcome? Yes, you can do that. There is a very simple way by which you can implement using in Java or OCI, whatever, that what was the outcome of that. When replay is not enabled. So there are certain cases when I say replay is not enabled. What I mean by that is very simple, right? So yes, we try to take care of a lot of the default things, but sometimes we say, no, we cannot do this. And that's what I said, your configuration changes and all that comes in, right? For example, if you're using older classes or using the non-default service and all that, default service and all that, that's a bad thing. SID and all that is bad. If you do certain things like I use DBMS output, but if you use, for example, some things like alter things and all that. And finally, this came to us as a very interesting scenario because we found out that certain target databases, one of our customers had this use case where they are using, they're trying to use AC or TAC-AC for failing to a different database. Now, we don't allow that. Because remember, I talked about the transaction outcome API that requires that database ID be exactly the same. And so that means, we can not use it with Golden Gate or third-party replication. We can use it with primary database because remember, DataGuard or primary database and standby database, they have the similar transaction ID. For DBMS rolling, we allow you for certain period of time because remember the DBMS rolling uses a mix of transaction primary standby database, and then the standby database is converted to logical standby and then converted back. So that should work for the part. That's why the asterisk is indicating basically to the part where it's physical standby, it's fine. So just to reset this, right? Certain things work fine as long as connection boundaries are, pools are returning requesting that back. Session state, if we need to do restore the session state, use failover restore. Again, DBMS app cont admin has a lot of those attributes. Side effects, TAC, we don't replay. AC, you can customize it, but then you require access to the code. Things like SYSDATE sequences, we have grants that we need to make sure that is provided to the owner of that application, especially in autonomous. So I have a slide that tells you specifically what needs to be done. Reset state, obviously we need to make sure reset states between request is done. And the good thing is with 19C, we by default do it. And as you can see, I keep saying with 19C and newer releases, we are overall trying to make sure that we keep improving it and automating it as much as possible. Finally, coverage. Remember that we may not provide 100% coverage. And so, but we do provide you the tools to find out. And if you're willing to work with us, we can make sure that the coverage is always increasing. So as I said, new in 19C, we now can detect, the request boundaries. So request boundaries, as I said, are the commit, between the point of begin and commit, we can detect this and automatically replay and all that. The other part is for explicit request boundaries are required for AC and recommended for TAC. For Oracle, what that means is with the typical Oracle UCP users or Oracle aware app servers or drivers, they do this all automatically. And for the app servers that work very well with us, as I said, but they're not Oracle owned like IBM WebSphere and JBoss and all that, they use UCP and Java standard. If they're using custom, then we need to make sure that we add those request boundaries. There are certain things that we need to make sure that they're restored before replaying. For example, if you have certain NLS setting or something, so you want to make sure that is set. For example, I'll give you we had this example case where with the older version of the driver, a customer was using the language setting for Spanish. And then when he was failing over or doing this replay, they found that it was doing in English and they were having all kinds of problems there, right? So as I said, in 19, we automatically do it. But if you're using an older version, you need to make sure this is done automatically for you. But I'm sorry, manually for you in the code. In 19C, we automatically do it. Certain things, as I said, I did DBMS output, but you can see that anything that does anything or any operation on the local, we cannot do anything. For example, if you're using a DBMS file or SMTP and all that, we are not able to do any replay with TAC. With AC, you can customize it, you can add code to customize it, but with TAC, the default, we don't do it. For example, if you're an app which uses DBMS file transfer or DBMS SMTP and we fail over, we will decide, and using TAC, we'll say we'll not replay that, and we'll give you an error. So as I said, you need to make sure that certain things like SYSDATE, timestamp sequences and all that, they need to be taken care of. Because remember, if you have an application that is inserting into a table from a particular node or instance, you have a sysdate and timestamp. When we fail over, we want to maintain that. You don't want to generate a new one on the new instance. So we kind of make sure that we take care of it. For sequences, you want to make sure that you grant all the for users so that this is easier for TAC to take care of. Reset session state between requests. Now, reset session state is because as sometimes we see certain applications will be using some sort of temporary work area, as we call it, right? It could be temporary tables, PLSQL globals, or whatever, and they try to work in that. This is not something that is logged into the database because remember, temporary tables and all those information is not logged. So it's very hard for the database to maintain state. So what we want to make sure is we reset state between requests. We don't want to use some of these temporary tables that are changed for one session to be used in another one. So we automatically reset state, and there's a service attribute which you can set, and there's also DBMS app procedure to do that. Most important thing, as I said, if you want to make sure that you know your protection level, as in when your app is how much your app is protected, and there is a very easy procedure that we provide. In lately, we have made it into an AWR report, so you can actually see this in AWR report. But essentially, what it tells you is you need to make sure your cumulative user calls in request and user calls protected is very similar. Now, for my simple Swingbench, it says it's similar. That's what the numbers are for. For your case, it may be certain number. It could be half of it. It could be 70% or whatever. Good thing is, actually 70% protection I have. And how do you get to that rest 30% is you go back to that questionnaire and figure out what to do so that you can get higher and higher. And also we have an AC check, which tells you what are the parts that need to be fixed. So let's say you run your AC check, we give you this report, and we tell you fail, warning, and all that. So most important part about it is if you say, for example, I have disabled it for certain reason, I'll give you 4.4.429 or whatever. We actually tell you the details, and we also give you the module name if you have a module information in your SQL or application or package. We actually specifically tell you what it couldn't do. So maybe in that area or that module or that application, you're using some of those things that I said you shouldn't be doing. Okay. So pretty much that is what I have. And then kind of like a summary slide in the end. I kind of make it more and more we are leaning towards, use TAC. Yes, there is a very good use case for AC, but if you don't know, just as I said, think about TAC. With autonomous, this has made it easier for you, so you don't have to do any thinking about it. But this is generally a very high-level part about how you can think about getting your applications benefit from the application continuity or continuous application availability feature, so that the database autonomous always makes it sure that it's available. Now you make sure your application is highly available because the entire stack, right? The middleware, the end user, and the database are highly available, which gives you a continuous application availability. That is my final slide. And I would. This is just again one. In case you need to reach out to me. I haven't looked at the questions. I'm hoping somebody was answering them. If not, I'm happy to answer anything now.
Excellent. Thank you very much. It was great, Anil. I think we had a few questions we already answered, but one I think is asking one thing here. I'm not sure if you are familiar with it. That's a database resident connection pool, right? Support for TAC.
Yes. So DRCP has had some issues with TAC. Yes, we are working on it. And as I say, if you have a very interesting case, feel free to reach out to me. We can work together to get that answer, get that going. I'll be happy to work with you on that.
All right. That's great. One question asked is someone not receiving the details about recorded sessions or the deck. Yes, I can. I'll make sure. So what happens is after every session, you guys should be able to come back to our page. So this is the page here, ADB Learning Lounge. And then with that, you guys are going to be able to go back and get the links. When you go to the session recording, in the session recording, I'll have the slides right there. So the slides, there's a link to the slides, and you guys can click on that. All right. But I'll make sure that you guys get that. All right. So we have a few others coming in, Anil. So I'll let you read through.
Yes. Yes. So I think I hear, can AC be demonstrated with the ADB-S using Swingbench? Yes. And Abhijit, if you have issues, let me know. But we have actually a video of it, which was used, I think, last year in one of our sessions where we displayed this. So this is something you should be able to do. The question from Cristiano is UCP could be used for ATP-S instead of active gridlinks. Well, gridlinks is actually, what I say, should have coverage. So you don't need to replace active gridlinks with UCP. Again, this works out of the box, and if you have issues, let us know, because that is something that should work automatically, Cristiano. From Hari, if we have a single node and have ADB-S and my application does not use connection pool, what should I use? Well, again, that is a very high-level question, right? With ADB-S, yes, you have a single node, but if you need to do planned maintenance, the benefit of a planned maintenance for your application could be different. For example, if it's just moving the single instance. Well, I shouldn't call it single instance. The one instance to the other node, you still benefit from certain kinds of failures. If they don't use, connection pool, that's perfectly fine. We support both. Remember, TAC, you could actually have direct connections. As long as you don't use the default service and some older drivers, you should be, much better than you. How much will you be protected is something that you can use the AC check to find out. Okay. I see Cristiano's question, is switchover a good way to test TAC AC with ATP to simulate, for example, a planned patching window? Yes, as long as the drain timeout plus switchover time is included in your planning. Yes, that is something you could do. All right, I think that is the last of the technical question.
Mm-hmm.
Thank you so much. Thanks again for having me.
Sure, absolutely. Yeah, so, and then if you guys want to continue typing your questions in, I'll make sure to get them to Anil and get back to you guys, all right? As always, keep a look on the ADB Learning Lounge. So we already have next week's session is there. It's going to be OCI disaster recovery for the full stack, right? The full stack disaster recovery and how that works with Autonomous Data Guard. I think that's it. So again, thank you very much, Anil. I really appreciate it, the session. And thank you very much, everyone, for staying. I'll leave this channel open. I'm not going to end the call. Just leave this running. And if you guys still have questions, just type them in. We're going to keep a look in the Q&A and see if we can type in answers for you. But other than that, again, thank you for joining. I really appreciate you guys coming.